Cool. Why don't we get started? My name is Ben Hagan. I'm here today to introduce the talks and the rest of the day to you. Thank you so much for coming to the SANS AWS Insecurity Summit. This is the first iteration, but the second time we've done this. We were just in DC on Friday giving the same spiel to everybody there. And hopefully this is something valuable to you that can help introduce some kind of modern security issues within cloud environments. And specifically today, we're focusing on Amazon, Amazon Web Services as kind of the environment of choice. Before we get further on, I'd like to talk a little bit about the agenda today. First, you're going to have to listen to me for about 30 minutes, but then we're going to move into what we're calling the case study portion of the day. We have three incredible people giving you some information on how their organizations are using AWS in a very kind of modern cloud-first style and how they've been solving some of their security issues. We have Will from Netflix. How many people here are Netflix customers or know what Netflix is? Great. So they're one of the largest consumers of public cloud in the private sector and have been doing it for many years now. Just for a little bit of context, I worked there for about 5 years. So when Will tells you a problem, I'm probably the one who caused that problem. And he's now dealing with cleaning up my mess, basically. We have Mark from Riot Games. Anybody here heard of League of Legends? One. The joke that I always pull is that it's Riot Game, not Riot Games, because they only have one game, really. But who knows? So League of Legends is one of the most popular online, multiplayer online games in the world. They pack stadiums regularly with their tournaments. They have $1 million prizes, that kind of thing. But they have incredible scaling needs. And that entire work is within AWS. Then we have Steve coming up to talk from Lyft. Lyft is obviously a ride-sharing company. Has anybody here used Lyft before? Absolutely. They're interesting because they are cloud first. They kind of came about during the age of public cloud. And their entire infrastructure was built out with that in mind. So they've been able to take advantage and build a lot of interesting tools to make sure that they can achieve their security goals there. So that's the morning sessions. In the afternoon, we have two parts to what we're calling training. The first part is really an interactive panel. And by interactive, I really encourage questions and comments. And if you have stories from your own organizations that you think contribute to what we're talking about, I would welcome you to bring them up. But we're basically going to dive into the top 10 problems that we've identified within AWS environments and go into them at a deeper level and try and talk about solutions. And we'll go through the different organizations and talk about what they're doing to solve for those problems. In the second part, we're going to try something that may or may not work out well, but kind of an on-stage, as you watch it, live coding exercise. The goal here is to introduce a little bit of Lambda, a little bit of Python, a little bit of Bodo. These are all tools to interact with AWS, and they're really what allow you to level up and do a lot of automation, scripting, and that kind of thing. So we're going to try and demonstrate, what the power is behind this and see how far we can go there. And just so that we have an idea of who we're talking to, how many people in the audience are actively using AWS in a day-to-day basis? That is almost everybody. That's great. And how many of you would say that you're familiar with Lambda events or programming for Amazon? That's amazing. Cool. So some of this will be a little familiar to you, but hopefully we can talk about some new kind of solutions that we're coming up with and introduce you to some new open source tools that can help you along with your day-to-day work. So with that being said, let's talk a little bit about the state of cloud security. And this is a security conference. You're here for SANS. So I felt the need to include the mandatory security images that you see in every other security presentation. And these have no relation to what we're actually going to be talking about, but I'm just getting them out of the way. So we have the This Is Fine dog. We're talking about cloud security. It's fine. We have Disaster Girl. Don't know exactly what that's going for here. We have Hacker Man. Of course, everybody loves Hacker Man. We have the 400-pound hacker. That's got to be there somewhere. We have some stock art of what you're trying to protect your accounts against. And then because every presentation deserves to have this, my two lovely cats. Kinako and Anko, they're beautiful. Now that we have that stuff out of the way, let's talk about security in the cloud. And I think when we talk about the state of cloud security, we can't ignore what's been going on over the last year. We have a number of news articles coming up, and each of them kind of gets scarier and scarier. AWS seems to be a common topic for breaches nowadays. And more often than not, it's because of a simple mistake that people are making. And I think when we look at these breaches that are happening, here we have one where I believe an NSA S3 bucket was left open, and a lot of interesting information was identified there. As we talk about these, there's some common themes. And these are what we really tried to identify in the top 10 issues that we're going to be talking about throughout the day. These are issues that we're seeing in the wild when we see articles like this, and these are issues that we're solving for internally within our organizations. Here we have the Uber breach. This is one of the more famous ones, led to kind of a lot of changes internally within Uber. And really, this was just a case of some developer credentials getting stolen, and then PR getting out of control, probably. We have FedEx. I think all of us have probably used FedEx at one point or another, and if our personal customer information were to be released, we'd be pretty upset. But again, S3 buckets are kind of the cause here, and we'll see this in the top 10 list, but these are problems that should be solvable, and we really shouldn't be having in modern environments. We have Accenture, one of the more popular contracting companies out there. Again, one of their most important responsibilities is protecting customer information. And if we can't trust our consulting or contracting companies to do that for us, I'm not sure where we'd be. Finally, one that didn't get a ton of press, but Splunk had an incident late last year as well, cloud-related, a security tool that we probably all love and use daily. Again, we kind of expect things to be a bit better nowadays. So I think this is setting the stage to demonstrate that this really is a problem. Tons of customers are using Amazon. Tons of companies are using Amazon. And as security professionals, we really need to understand how the environment operates and how we can secure it on a day-to-day basis. So I think the thesis I would like to propose for today is a little different. And it's something I do genuinely believe. And it's that if we have a well-architected and instrumented account, we can actually make it more secure than we could within a traditional data center. And I think, from my point of view, this speaks to the power that having an API-centric environment gives you, the power of having something that's scalable and responsive, and the power of having something that if you put the right amount of thought into it, you can actually embed security into the kind of fabric of the environment. And these are capabilities that you might have in like the best data center environment, but let's be honest, they're not capabilities we have in most data center environments. And I think you could theoretically cobble this together if you're using things like any sort of open source virtualization technologies or data center level kind of containerized environments, that kind of thing. You could have a lot of this, but you don't have it in the ecosystem that Amazon provides you. And this is not an advertisement for Amazon, but I do think they're a couple years ahead of the competition here. And that's why we're choosing to focus on them today. If we understand how to secure an Amazon environment, I think the industry is naturally progressing to a common set of controls, such that if we understand Amazon today, we'll understand the competition within the next couple of years. So I have an asterisk at the end of here, and that's really to signify that the important part here is that we have a responsibility to know what we're doing in securing this environment. It only works if we know how to use it. And the naive assumption that just by going to Amazon we have something more secure is going to be what bites us in the ass. So I think if we bring that all together, what it means is that the state of cloud security really should be better. We have all of the tools available. We have all of the bits and pieces that we need to make a really compelling and secure environment, but the industry itself is failing. We're having stupid mistakes. People are finding them. They're being exploited. We should be doing better. And that's the intent of the event today, is to try and bring us further towards the conversation we need to have with ourselves to make sure that we can kind of level up security for these new environments, and that we can actually leverage them for the betterment of themselves. So we're using the tools that people use to deploy. We're going to use the same things to secure the environment. Who knows what this is? Yep. It is the division of responsibilities that Amazon will tell you. Anytime you talk to them about security or operational responsibilities, they will bring up this division of responsibilities and tell you that they have a certain set of responsibilities. As a customer of Amazon, you also have a set of responsibilities. And specific for security, this is important. Amazon says that they own essentially the hardware. And if it's a managed service, they own up to the service layer. But as a customer, you are entirely responsible for the configuration of your account. You are entirely responsible for the operational lifecycle of your account. You are entirely responsible for the monitoring and logging of your account, as well as any number of other things. And I think the key here is that a lot of customers don't have this click with them when they start using Amazon. They think by going into Amazon, they have any number of problems automatically solved for them, and they don't. They just have the ability to solve them, or they have the tools necessary to solve them, but it's not given to them for free. And it's on them to make sure that things like security, availability, integrity are actually preserved within the cloud environment. And those are the kind of things we're going to be talking about today. So to dive in, we collaborated, the speakers and I, prior to today on a list of the top 10 AWS security risks that we have identified within our own environments and within publicly acknowledged breaches. And this is a first pass at a list. It's not going to be perfect, and we welcome feedback, both in terms of content and prioritization. No doubt this will change over time, but I think it's a useful vehicle for us to talk about these kind of things today and to carry the conversation throughout the different portions of today's event to make sure we have some consistency there. So I'm just going to go over the top 10 risks right now and give you the very high-level view in terms of what they are and what they cover. And then you'll be hearing more and more about them throughout the day. In the first part of the panel session this afternoon, we'll be diving into them at a much deeper level and actually trying to give recommendations and advice on how to deal with them. So the number one risk that we've identified is the insecure use of developer credentials. Amazon is API driven. Even if you're using the console, essentially the console is using the API in the background to do the work for you. And one of the worst things that can happen is having a set of developer credentials be set out into the wild and discovered. If an attacker has access to developer credentials, they essentially have access to your environment, commensurate with whatever the developer had access to. And there's any number of opportunities to escalate privilege and to actually pivot throughout your environment. So I think in terms of the breaches we talked about today, a couple of them were related to having developer credentials stolen or found in GitHub or any other kind of embarrassing situation. But it led to some very potentially critical situations occurring. Number 2 on the list, publicly accessible S3 buckets, and these come in 2 flavors actually. S3 is incredibly powerful. It's a object or file store, depending on how you look at it. And essentially many organizations use it as a way to store information. It's a great location as a data warehouse. You can store backups there. Many companies use it as a web server. You can actually serve content out of S3 directly. But the problem is that I would say the policies around security controls are pretty confusing, and a lot of organizations get it wrong. The default way to make something public does indeed open it up to the world, and unless you're having good hygiene and good accounting of what's out there, you're going to quickly lose track of what's available. And it's gotten a little worse recently just because we now have a problem where, interestingly, because of certificate transparency and a number of other things, we have a world where we can actually discover what's going on automatically and actually see what S3 buckets are open to the world. So who's familiar with certificate transparency? It's a few people. It's a new standard driven by some of the browsers out there that the SSL registrars should be publicly accountable to what they're actually issuing certificates for. So there's a lot of questions around trust and if we should trust registrars. One attempt at mitigating that is to have them publicly publish every certificate that they put out there. And this is going to be an increasing requirement over the next couple of years, to the point that probably every public certificate is going to be logged within the certificate transparency logs. The interesting thing is, when S3 creates a new bucket, you get a certificate for it automatically in the backend. So if we go through here, this is a tool called Bucket Stream. It's on GitHub. And all it's doing is looking at the certificate log for new certificates that match the domain namespace of S3. And if we look on here, these are, I just started writing this 5 minutes ago, probably. We've already picked up on a bunch. And without knowing specifics on what's in here, I'm going to guess that some of these are not meant to be public. And it's looking for two different conditions here. One is the publicly accessible via the web situation with S3, and the other is publicly accessible via the API. And there's a deceptive policy within Amazon, probably ill-named in many ways, but allowing access to all users. When you say all users, you might expect that it means all users within your organization. In fact, it means all users in Amazon anywhere. So if I have a user account in my own Amazon environment, I can log into your bucket as well. And that's just a misunderstanding in terms of what the control does, but it's actually caused a number of breaches in the wild. Next on the list, improper use of default configurations. And here we're talking about, really, I think the number one offender here is managed IAM roles. When you log into Amazon and you provision users or services, you're given the opportunity to give them an IAM, or Identity Access Management policy, that controls what they have access to within the rest of your environment. One of the problems we see is that companies are naively choosing managed configurations provided by Amazon and blindly assigning them to users or services. And the issue here is that these managed configurations change over time. And there's really no way of knowing when Amazon updates them without constantly polling and checking, and what additional permissions they're granting. So as Amazon comes out with new services or new capabilities or new features on a service, they may add these to managed default configurations silently. And suddenly, a user that you're very careful to choose the least privilege configuration for has access to more things than you intended. And occasionally, these lead to opportunities to pivot or escalate privileges. So we've actually seen managed configurations have a few unintended abilities to escalate privilege to root level credentials within your account. And they've corrected this, but you leave yourself open to mistakes Amazon is making as well. Number 4 on here, access controls do not follow principles of least privilege. And this is laziness, basically. And it's kind of the power of the cloud is biting us, because as we develop things for the cloud and as we have awesome new capabilities brought about by things like DevOps policies and practices, we have become a little lazy in terms of how we provision access rights. When somebody deploys a service now, they're generally, I mean, I speak for myself here as well, but as I'm trying to debug what kind of access I need, I often give myself a star capability, which means I'm granting myself a large set of privileges, either to the entire account or specific to a service. And that's probably not the right setting, especially if I'm intending to be least privilege here. There's a number of different strategies to mitigate this, but the best one is to make developers responsible for understanding what their applications need and making sure that their privileges match what their expectations are, and auditing this regularly. Again, garbage control is a function we need to do better within cloud environments. Next on the list, misconfigured network constructs. And I think from my point of view, and we're going to hear a variety of opinions, the biggest offender here is organizations that are trying to mimic their data center environments within their cloud environment. And Amazon, over the last couple of years, has really come out with an amazing number of very powerful networking controls with VPC, which is their kind of virtual private networking construct. You have a lot of capability here. You can configure subnets, routing tables, DNS servers, a lot of interesting things, but it's not a data center. And it doesn't have the full capabilities you would have if you had a hardware firewall sitting in front of you. And I think that naively sets people up for failure in terms of having a scalable environment, an environment that you can easily instrument, or an environment which lets you have the security controls that actually work within cloud available to you. Doing things like intrusion detection or prevention on the network layer is actually relatively difficult within cloud environments. And if you're approaching that, assuming it's going to be similar to a data center, is going to set you up for some very sad realizations. So I think misconfigured network controls are, it's key to understand networking capabilities and architect your environment for those straight from the beginning. Next on the list, lack of appropriate logging and monitoring. This is just good security practice again, but it's totally different than what we look at in most data center environments. We need to make sure that we're leveraging the built-in logging capabilities of Amazon. We have things like CloudTrail, which actually logs all of the API events that are going to Amazon. We have service-specific logging, like S3 bucket logging. And unless we know what that is and how to leverage it and how to build a pipeline for it, we're going to be losing capabilities that we might have had readily available within a data center. And especially in terms of incident response and being prepared for those kind of situations, we need to know what we have, and we need to know how to discover it. And I think logging and monitoring is the key to making all of that happen. Next on the list, a lack of inventory management. And this is, I think this is complicated actually, because in Amazon, for one of the first times, unless you had an amazing deployment strategy in a physical data center, this is one of the first times that most organizations can query an API and in a single call, get back a list of everything that's running in their environment. And that, to me, that is groundbreaking. Like, if I had that 20 years ago, my job would have been a lot easier. But nowadays, we have that ability, but it doesn't mean we know what's running where. And unless we have good inventory management telling us what is running on an EC2 instance or what is supposed to be in an S3 bucket, it really only gets us half of the way there, and it only tells us half of the story. So making sure that we invest the time and energy to do good inventory management on top of what Amazon already gives us is incredibly important. A lot of strategies involve tagging things, making sure that we can track owners through orchestration or something like that. And we'll be hearing today from the other speakers how their organizations solve this problem, but I can't speak enough to how important this is. If we have zero knowledge of context, we're not going to know how to secure our environments. Number 8 on here, domain hijacking. This is interesting because there's a lot of actual transitive trust within Amazon. When you think about configuring an S3 bucket to serve a website, you have to configure a DNS entry to point to it. If either of those gets out of sync, you set yourself up for some hijacking scenarios. There's a number of other services that are vulnerable to this, and we'll talk about them in the latter half of the day. The key here, though, is, again, this is a hygiene issue. As long as you're configured in a way that you know when one of the two sides of trust is changing and you clean up the other side, you'll be fine. But it's actually really hard to track that. So domain hijacking is kind of a sleeper one in here, but I think it's very important. Number 9, lack of a disaster recovery plan. Again, this is one that people think they get for free within Amazon, and they don't. And by disaster recovery, I think we need to include regional failure as part of disaster. And we need to include the ability for your service to survive regional failure. So cross-region capabilities are important, but also considering what a catastrophic loss of your account would mean, either through compromise or through, God forbid, like Amazon going down or going out of business. Understanding what that means for your environment is key. And I think the kind of cliche situation now is something called the Code Spaces incident, which happened a couple years ago. They had their account compromised, taken over, so they got locked out of their own account. And it was held for ransom, and they refused to pay it. And the attackers deleted their Amazon account. And they did the analysis, and basically it was identified that it was too expensive to recover to actually remain in business, and they just shut their doors. This is a scary situation if you're reliant upon Amazon, and you really need to consider what it means to be ready for disaster recovery within a cloud environment. Number 10, manual account configuration. This is just one where it's a good practice not to use the console whenever possible. Using the console introduces manual processes into your environment. And really, the opportunity here is for automation, for scalability, for consistency. If you're constantly logging into the console to make changes, then you're not going to be able to scale and interact with your environment the way it needs to be interacted with. From my experience at Netflix, they have a relatively small team to actually do cloud security work, and they have one of the largest environments in the world. The key learning there is that scripting and automation is key to scaling your team and scaling your capabilities. And if you're constantly locked into the console, you're just not going to be able to do it justice. And I'm going to actually commit my own sins later today by going to the console a lot to show you some things. But we'll get into that later. We have one bonus item here. Who here in the audience can tell me what this is? Anybody? Except for speakers in the latter half of the day. Over here? That's right. So it's the AWS metadata service. And this is an ingenious way to give your EC2 virtual machine instance context within its cloud environment. Essentially, they have a web service running on the hypervisor layer for every compute instance you deploy. If you go to this 169 address, you'll see a RESTful API of data around what your instance is, how big it is, how long it's been up, what region it's in, a lot of interesting information. But this service is also how your instance gets identity. And that identity is what lets us access other services within Amazon. And this is actually, it's a great way to approach identity, but you also have to protect it. There's a relatively trivial set of vulnerabilities that we consider kind of low, medium risk typically in most environments, where a web application would issue a request to a remote server, and somehow it gets proxied back to the user. So if you think about a true proxy, that's exactly what's happening. But there's a lot of deceptive areas where this pops up as well. If you're getting like state of machine that's directly reaching out and providing the information back to the end user, lots of opportunity here. The problem is any service running on your machine has access to this information. So if you have a web service deployed and it's making web requests out and returning it to the end user somehow, and I know that you're on an Amazon box, I can try and send it to this address and get back the identity information for your box. And then I can use that on my local machine to access your Amazon environment. It gives me the credentials I need to interact with your Amazon environment just like this service does. And that's pretty dangerous. So it's a relatively benign vulnerability in most environments, but here it becomes critical and incredibly dangerous. And we'll talk a little bit about identity and how to protect against that later today. So those are the top 10 plus 1 risks within Amazon that we've identified. Again, this will be a common theme throughout the day. We talked about some of the kind of issues that have bubbled up within cloud environments recently. We talked about some of the breaches. We've covered these 10 issues. But I do genuinely think that there are more opportunities than problems within cloud environments. When I look for jobs now, I want to work within public cloud because I think it's one of the most interesting spaces within security. But as security professionals, it's on us to understand what we're doing and how we can actually secure these environments. And hopefully the event today is one way that we can contribute back to the industry and grow this community of people that are trying to solve these problems. And I really look forward to the conversations we're going to have today. Please don't be afraid of asking questions. We are simulcasting this, so if you have a question, please wait for the microphone to come around. But I think it's really the interaction and conversations that we're all looking forward to. So with that, I wanted to thank you so much for coming out today, and let's hear from our first speaker. Will? Thanks.